This is hand-eye calibration in the Augmentus software. It measures the offset between the scanner and the robot flange, the value every scan-based operation depends on. This walkthrough runs one end to end. The workflow has 4 steps. First, open the calibration panel from the scanner tool. Second, estimate the sphere center. Third, run the automated calibration. And fourth, save the result back to the robot. Let's walk through each one. Before starting, the software and the scanner both need to be connected to the perception server. No project can be open. An active project conflicts with robot communication and scanner state. Take the protective glass out of the scanner casing. It refracts the laser and costs you accuracy. And place a calibration sphere in the scanner's field of view, the only round object in frame. And confirm the scanner itself reads unaligned. On the web interface, not by assumption. Position the sphere so the laser cuts 1 to 3 millimeters off the meridian. The profile then reads as a clean semicircle. Cut through the center instead, and the scanner reads the full radius, no longer matching the sphere radius you entered. This is the physical jig. A calibration sphere on the base, laser visibly off the meridian. First, on the industrial PC, open a browser at the scanner's IP address. The profile view is where you watch the laser cross the sphere. Open the exposure tab and adjust the exposure until the sphere reads cleanly against the background. Then confirm that alignment reads unaligned. Any other value transforms the profile data before calibration ever sees it, producing a wrong result with no visible error. In the Station's Tools tab, select your sensor. Here, the Augmentus line G425. And open its TCP tab. Press Calibrate, and the Hand-Eye Calibration panel opens on the industrial PC. Hardware configuration fills in from the connected hardware. Confirm the sphere radius. Both estimation and calibration drive the robot on their own, so before either one, clear the cell of personnel. Keep the emergency stop within reach. Now press Begin Estimation. A joint values check appears first. Check those joint values against the teach pendant before any motion starts. The robot works through 9 estimation poses to locate the sphere center, and the first results fill in as it goes. With all 4 fields green, verify the estimated TCP against the initial TCP, within tens of millimeters and a few degrees. More than 50 millimeters on any axis indicates a setup issue. Check sphere position, sphere radius, and profile quality before proceeding. Poses opens the pose settings form. Leave the standard preset alone unless a calibration comes back inaccurate. With the estimate confirmed, press Begin Calibration. The robot now drives the full pose set automatically. The counter shows reachable poses only. Unreachable ones are filtered out before motion begins. When it finishes, the panel reports the calibrated TCP, position and rotation together, with its translational and rotational uncertainty, and a quality status. Here, OK to validate. OK to validate means the alignment error came in within the acceptable range. Not that the TCP is accurate. Thin rotational diversity still passes. Low uncertainty is no guarantee either, but values well above your previous runs are a reliable signal to rerun. Press Save TCP. The button confirms with TCP saved, writing the value into the server configuration. Then, back in the Augmentus software, press Get TCP to pull the new value across. Then apply the change to the tool. A quality status describes the solve, not whether the TCP is right in your cell. So prove it with a scan. A good one comes back as one continuous surface. A bad one splits. Look across the surface. The 2 passes don't line up, so the layers sit apart. Rerun the calibration before you trust it. And that's hand-eye calibration. Check the alignments, estimate the sphere center, run the pose set, and save 1 TCP back to the tool in minutes, not an hour.